Hey students, here is your lesson on 2.7 dilations. So our key idea here is that a dilation is a transformation in which a figure is made either larger or smaller with respect to a point called the center of dilation. So this is the first transformation that we've talked about, which does not result in a congruent image. Instead, it results in a similar image. So if we look at this first example and tell whether the blue figure is a dilation of the red figure, we can see that in example A, yes, it is a dilation because the blue figure is smaller than the red figure was, so it got smaller. But in example B, it is not a dilation because they are the same size. This looks more like maybe a translation. Okay, so a few more key ideas here. The scale factor is the ratio of the side lengths of the image to the corresponding side lengths of the original figure. So if we look at this original figure ABC, it has a side length of 2, and the image has a side length of 6. So the ratio of the image to the original figure is 6 to 2, or 3. So this blue image has a scale factor of 3 compared to the original figure. Now, to dilate a figure with respect to the origin, all you need to do is multiply the coordinates of each vertex by the scale factor, which we show with this lowercase level, the lowercase letter k. So here we have this point 2, 0 is C, and then C prime, we multiply 2 times 3 to get 6, and 0 times 3 is still 0, so C prime is at the point 6, 0. Now notice that in our example, the scale factor, or the k value, was 3, and when the k value, or that scale factor, is greater than 1, the dilation is an enlargement. It's bigger than the original. When k is greater than 0 but less than 1, the dilation will be a reduction. It'll be smaller than the original. So let's go ahead and look at this next example. We're going to draw the image of triangle ABC after a dilation with a scale factor of 3. So let's first go ahead and draw the vertices of ABC. We have -1, 3 is where A is, 3, 0 is B, and -3, -2 is C. So here is triangle ABC. And then what we're going to do is just multiply each of those coordinates by 3. So we're going to do -1 times 3 will be the x coordinate of A prime, and 3 times 3 will be the y coordinate of A prime. So our vertice here will be -3, 9. Okay, we'll do the same thing for point B. We'll multiply 3 times 3 for our x value, and 0 times 3 for our y value, which gives us 9, 0. And then our last point, we'll do -3 times 3 and -2 times 3, which will be -9, -6. Now let me use a different color here to go ahead and draw the image, our dilation. So A prime, we said, was at -3, +9. So that's up here, A prime. B prime is at 9, 0, so that's right about there, B prime. and C prime is at -9, -6. So that's here. So I can go ahead and connect those points. And I can see that the triangle I've created in that image is similar to the original, although not congruent because it is an enlargement. Okay, in our next example, we are going to dilate a figure, and this time we're going to use a scale factor of 0.5. So we see that that's less than 1. That means our dilation will be a reduction. So let's go ahead and map W, X, Y, and Z onto our coordinate plane. So we have -4, -6. That's W. We have -4, +8. That's X. We have +4, 8. That's Y. And we have +4, +4, -6 is Z. Okay, so that is our original rectangle. And what we're going to do is multiply each of those X values and Y values by 0.5. I might write this as 1/2 because I think it's going to fit better on here if I write it as 1/2, because it means the same thing. So here I have -6 times 1/2. And let's see, that means that the point W prime will be -2, -3. Here I have -4 times 1/2 and 8 times 1/2. That gives me -2, 4. Here I have 4 times 1/2 and 8 times 1/2. That gives me the point 2, 4. And last I have Z. And for Z prime, I'll have to multiply each of those values by 1/2. And I get 2, -3. So let's go ahead and put those points on the coordinate plane. So -2, -3 is right here. That's W prime. -2, 4 is right here. That's X prime. Y prime is at 2, 4. Y prime. And Z prime is at 2, -3. Okay, so here is my image, which is a dilation, and the type of dilation is a reduction. Okay, let's go ahead and look at example 4. And this time we're going to be using more than one transformation. So we have a trapezoid A, B, C, and D. Let's go ahead and put A, B, C, D on our coordinate plane. So I have -2, -1, that's A. -1, 1 is B. 0, 1 is C. And 0, -1 is D. Okay, that is a pretty tiny little rectangle here. But luckily, we are going to use a scale factor of 2, so we're going to make it a little bit bigger. So I'm going to use green for my first transformation. So I'm going to go ahead and write my coordinates here too. A prime, B prime, C prime, and D prime. So here I'm just going to take -2, -1, and I'm going to multiply by 2. I'm going to take -1, 1, and multiply by 2. I'm going to take 0, 1, and multiply each number by 2. And 0, -1. Okay, so then I'm going to go ahead and map those. I'm going to put those on my grid. So here's A prime, and negative 2 B prime is right on top of where I had my original B listed, but not the point itself. Okay, and then here is C prime, and here is D prime. So you can see that our new shape, our image, is bigger because we used a scale factor of 2, so that was an enlargement. And now we're going to go ahead and translate this shape 6 units to the right and 2 units up. So let's go ahead and write each of our coordinates here. A double prime, B double prime, C double prime, and D double prime. Okay, so remember when I'm translating to the right, I'm adding to my x value. So in this case, I'm going to add 6. So instead of negative 4, my x value will be positive 2. Instead of negative 2, it will be at 4. Instead of 0, I'll have 6. And instead of 0, I'll have 6. Okay, so that moved it 6 units to the right. Now I'm going to move 2 units up. So I'm going to look at my y coordinate, and I'm going to add 2 to each. So this is going to be at 2, 0, 4, 4, 6, 4, and 6, 0. So let's go ahead and put that on our coordinate grid here. So I've got 2, 0. That's going to be where A double prime is. And then I have 4, 4. That's going to be B double prime. Then I have 6, 4. That's C double prime. And 6, 0 is D double prime. So here is my new shape. So it's been dilated and then translated. All right, go ahead and try the on your own. Don't forget that you can look back at your notes for help.